Okay, so what we're looking at here is something called eutectic systems. And what we're looking at with eutectic systems is magma melt, where we have got a mixture of two different minerals in there. Now, we're just looking at the simplistic version, where we have got a composition of melt A and melt B. So we're not giving them names, we're not worrying about the actual minerals on this. We're just going to call them melt A and melt B to help us understand the process that goes on in these eutectic systems. So what this scale along the bottom shows us is the composition, either molecular percentage or weight percent of the two minerals. So let's say, for example, we have a melt composition that is 80% melt mineral B. So 80% mineral B would be here. So if we track that upwards, let's put a line running down here. Now that, as I said, is 80% melt B. Now, what happens is, we've got the temperature scale on the left-hand side here. As the melt or magma cools down, what we expect to happen is crystallization, obviously, because it's the system's losing energy. What is we follow this line down here until we get to this line called the liquidus. Now, the liquidus is the point at which some of the melt starts to turn into solid. And in this instance, what happens is mineral B starts to crystallize. So what we have at this temperature here, so that's about, say, 1430 degrees Celsius. At about that temperature, crystals of B start to form. Now, what will happen as crystals of B start to form, that the remaining melt, the remaining liquid, will become depleted in B. So here we've got melt and B. Us, B is crystallizing. So that turns to crystals. What happens is, as the temperature drops further, we follow the liquidus downwards. See the temperature's dropping to here, so it's dropped to about 1400 degrees Celsius. Now what we've got is, if we follow that line down there, we've got a melt, which is approximately 72, 73% of mineral B, and then obviously 27% mineral A. And that's because that mineral B has already crystallized. So obviously, if it's already crystallized, there is less of it in the entire melt. So as it cools down further, the temperature drops. We'll move down towards this point here, where everything crystallizes. Now, what that there is called is, it's the eutectic point. And that's the point at which everything crystallizes. You've got TC there, which is temperature of crystallization. Okay. So that is one example within that eutectic system. Now, depending on the composition, it determines which mineral will crystallize out first. Let's take a mineral of composition of 20% mineral B. So we'll draw a line down there. 20% mineral B. And as that crystallizes, as that cools down, sorry, we get to the liquid is there. Now what happens here is, because we're on this side of the eutectic diagram, mineral A will crystallize out. That means our melt becomes depleted in mineral A, and the proportion of mineral B will increase. At this point here, at, say that's about 13, 20 degrees Celsius, we would have a composition of, what's that, about 36% mineral B. So you can see that we've become depleted in mineral A. Obviously, that will continue to move down until we get to the eutectic point as well. And obviously, the eutectic point meets the surface, that point at which everything crystallizes. Now, the eutectic point is a point at which we've got all three phases, liquids and both solids can exist. Now, if the melt crystallizes at that point, the final crystals will equal in composition the original melt composition. That's assuming we've got an enclosed system where nothing comes in, nothing can leave. But an important thing to remember with phase diagrams is that whatever starting composition you have, your final crystallized composition will be exactly the same. Okay, so that's your summary of phase diagram.